Hello, everyone, and welcome to Solving One-Step Equations. My name is Arthur Morris, and we're going to go through the process of solving equations. All right, so this is a complete process that I like to use to solve equations. So if you want to take a minute and pause the video after I go over these steps, then that'll be a good idea to write these down. The first thing we want to do is to multiply both sides of the equation to clear fractions if we have fractions. You don't have to necessarily do that, but it helps to eliminate the fractions and finding common denominators and working with fractions throughout solving the equations. The second step that we use is to clear the parentheses by using our distributive property. Then we collect like terms on each side if we have them. Then we get all the variables on one side, all of the variable terms on one side, all the terms that do not have variables with them or the constant terms on the other side of the equal sign using our addition principle. And we collect like terms again if necessary. And then we multiply or divide to get the variable all by itself to make it into 1x or 1v or whatever the variable is. We only want one of them. And you can always plug your answer back into the original equation in the place of the variables and simplify to see if that is a true solution. Okay, so let's go through a few examples. This first example, we have x plus 7 equals 20. So we're trying to find the value of x that would make this equation true. Well, we all know that 13 plus 7 equals 20, but there's an algebraic way to figure this out. Our algebraic way states that our goal is to get x on one side of the equal sign all by itself. So if we have x plus 7, then I can subtract 7, and that'll take away the 7 from my left-hand side. But this is like a scale, a balancing scale. So whatever I do on one side of the equation, I have to do on the other side of the equation to keep it balanced. So I'm going to subtract 7 there also, and that gives me x equals 13. Again, mentally, you can plug that back in. 13 plus 7 equals 20. All right, x minus 2.4 equals 2.8. So since we have x minus 2.4, our goal is to get this minus 2.4 removed from the left-hand side. So we will balance it out by adding 2.4 because negative 2.4 plus 2.4 is 0. But again, whatever we do on one side of the equation, we must do on the opposite side of the equation to keep the equation balanced. So I need to add 2.4 to the right-hand side also. So it gives us x equals 5.2. Okay, what about 2 times x equals 12? Well, that's saying that 2 times some number equals 12. We all know that 2 times 6 equals 12. But algebraically, if I want to undo this, I have a couple of choices. If I have 2 times x, I can divide by 2 because 2 divided by 2 would give me that 1x that I want. Again, I will come over here and divide by 2. Or I could have multiplied by the reciprocal because any number times the reciprocal is 1. So I could have taken that same problem and multiplied by the reciprocal of 2. The reciprocal of 2, remember, that's just flipping the number. It's 1/2. Any number times the reciprocal is 1. So if I come over here and multiply by 1/2, well, 1/2 of 12 is still 6. So you get the same answer. Okay, so what about negative 4 times x equals 15? Again, our objective is to get positive 1x. So since I have negative 4 times x, then I can divide both sides by negative 4. Because negative 4 divided by negative 4 is simply 1x, understood 1. And we will just leave that in fraction form. Now, we normally don't leave negatives in our denominator, so you can put that negative out to the side of the fraction or up top with the 15. Okay, let's look at a couple more examples. 1/2 x equals 20. 1/2 times x equals 20. Remember, our objective is to make that into 1x. And we just stated on the previous couple of problems back that we can multiply a number times its reciprocal and get 1. So since I have 1/2 times x, then my only choices are to use multiplication or division to undo this. So I'm going to multiply by the reciprocal of 1/2, which is 2 over 1, or just 2. Whatever I do on the left-hand side or on one side, I have to do on the other side. So 2 times 1/2 is 1x. 20 times 2 is 40. And that makes sense. If we plug 40 back into the place of x, it will be 1/2 of 40, which equals 20. So that makes sense. Okay, and the last example here, -3/4 times x equals 12 over 7. Again, our objective is to make this into 1x. Right now we have -3/4 times x. That tells me that I have to use multiplication or division to undo that. So I'm going to choose to multiply by the reciprocal of -3/4, which is -4/3. So I'll come over here on my right-hand side and multiply by -4/3. -4/3 times -3/4, any number times the reciprocal is simply 1. Now on the right-hand side, when working with these fractions, I like to simplify my numerators and denominators if they have common factors, which the 3 and 12 do have common factors. 3 will go into both of these. 3 goes into 3 once, 3 goes into 4, or 12 4 times. So I have 4 times -4, which is -16, and my denominator, 7 times 1 is 7. Okay, hope you found this video to be helpful. Thank you.